So we looked at the discharge of the Mississippi, hundreds of thousands of CFS. The Colorado has a really large drainage area, but look how small the CFS is, 15,000 CFS. It has a really low discharge. The reason is, think of the difference between the precipitation in the east and in the west, right? We saw that area on the map where it's all green. There's a lot of precipitation on the eastern United States, and in the west, way less precipitation. So the Colorado starts out as snowmelt, and the way a watershed would work, say eastern United States, like normal conditions, is in the top of the watershed, you would have a low area and precipitation in that watershed. As you go down the watershed area gets bigger, and there's more area for more precipitation. In the western United States, the streams start, like the Colorado, as snowmelt high in the Rockies. And then as it goes down its pathway, the watershed gets bigger, but there's not a lot of rain. There's lots of evaporation, and we're irrigating the heck out of it. So it doesn't increase the drainage over time. In fact, it can decrease. When the Colorado River gets to Mexico, it doesn't even reach its delta anymore. So here is, we've looked at the Salton Sea. There's the Salton Sea, and this is, through here is the big canal, I think it's called the America River, that pulls water off of, here's the Colorado River coming down. We pull water right off of the Colorado to irrigate these fields in here, and then that drains not back to the Colorado, but up into the agricultural sump of the Salton Sea. So the river then hits the border, the international border of Mexico, and flows down and would end up down here at its delta, but it doesn't. Here is the delta. So it is a big area of salt accumulation, because it's also like a desert environment down in the Gulf of California. All right, zooming out a little bit. Here's the Colorado River coming in. Here's all the irrigated farmland. This is in Mexico. Then it flows down and intersects with salt water. This is salty water coming here. These are salt flats that have formed as the water evaporates. These kind of giant sandbars down here are old sediments from before Hoover Dam was built, and the Glen Canyon Dam was built backing up sediments in Lake Mead and Lake Powell. So these are pre-1950 sediments. There it is. So it's doesn't reach its delta anymore. Oops. If we zoom out, here is a look at the southwestern United States. Right, and here is the Grand Canyon. So we go up to the San Juan Mountains and the other parts of the Rockies. That snow melts, feeds these tributaries. They come down and form the Colorado River. This is the dam here that makes Lake Powell. Then we go down into the Grand Canyon, and then there's Hoover Dam, there's Nevada over here, and then all these little bodies of water in here are dammed areas. And then starting here is where we start to get irrigation. This green lobes here are the fields of agriculture. Here's the Salton Sea, more agriculture, and then just below the border, more agriculture. So we look at it zoomed in, and those are the dams. So the first one there is the Glen Canyon Dam at Lake Powell, right around the border. And then Hoover Dam, Davis Dam, Parker Dam, the Imperial Dam, the Laguna Dam. The Imperial and the Laguna, those are kind of specific to that irrigation around the Salton Sea. So we really dammed the heck out of the Colorado. It's not really a free-flowing river like it used to be. Go back and watch that video Red again. It talks about how we use the heck out of the Colorado River. Salton Sea, we've already talked about the environmental implications of transferring water and what is going on at the Salton Sea with salinity levels and the exposure of those lacustrine sediments and how that can be a health issue. the saltiness of the water, the pesticides flowing into the water. So I won't go too much into that there. So read back over your Salton Sea notes. Oh, and bird migration, a lot to that story.